Hi. These are going to be the solutions to the first homework. Okay. So homework one. Right. So it's the homework sheets. Yesterday's lesson. After yesterday's lesson. So let's look at some of the problems. So number one on the sheet. Define a sample space S for each of the following experiments. So for A, there's 5 types of coffee. A, B, C, D, E. Those are the 5 labels. And so a best tasting and worst tasting brand are to be chosen, and the labels are to be recorded. And so let's say we put the best tasting one in the first coordinate of an ordered pair, and I put the label for the worst tasting one as the second number of an ordered pair. Then capital S, the sample space can just be the set of ordered pairs where I put one letter from the first quarter for the best and one letter for the worst. So let's say the best one was A and the worst one was B. Or the best one was A and the worst one was C. The best one was A, the worst one was D. The best one was A, the worst one was E. Or the best one was B, the worst one was A. The best one was B, the worst one was C. The best one was B, the worst one was D. The best one was B, the worst one was E. Now we just keep going. The best one was C, the worst one was A, the best one was C, the worst one was B, the best one was C, and the worst one was D, and the best one was C, and the worst one was E. Or the best one was D, the worst one was A, the best one was D, the worst one was B, the best one was D, the worst one was C, the best one was D, the worst one was F. And then the best one was E, the worst one was A, the best one was E, the worst one was B, the best one was E, the worst one was C, or the best one was E, and the worst one was D. Okay, that's the sample space, 1A, for experiment A. Okay, so that is what number one is asking me to do, is finding the sample space for each experiment. And so 1A, you get this. Okay. So let's look at 1B. So 1B, randomly arrange the letters A, T, and C in a row. Record the arrangement of the 3 letters. So we're going to randomly arrange the letters A, T, and C, and what we want is a sample space for that. So just arrange them. So you have A, T, C as an ordered triple. You have A, C, T. You have T, A, C. You have T, C, A. You have C, T, A. You have C, A, T. And so that's a set of ordered triples. That's the sample space for this experiment. And let's look at part D. Part D is toss a coin 3 times and record the outcome after each toss. So we're going to 3 times, outcome after each toss. H is heads, T is tails. So what is it? It's going to be 3 times. Okay, so heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. And that's the sample space for part D. Okay, and so these are 3 of, this is A, B, and D of number 1. Okay, so hopefully that makes sense. So you need to know how to find the sample space of an experiment, the set of simple outcomes. So, okay, so that's number 1. Let's look at number 2 on the homework sheets. Okay, so number 2 on the homework sheets. So a student guesses the answers to 5 true-false questions, set up an appropriate sample space for this experiment, then determine the subsets representing each of the following method. Okay, so we need the sample space for this one. There's 5 true or false questions. So, for instance, he could say true for all 5 of them. Okay, so he could guess the answers to true to all 5 of them, or he could say true, 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 false. Or he could say true, 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 false, true. Or he could say true, true, false, true, true. Or he could say true, false, true, true, true. Or you can say false, true, 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 true. So first there were 0 falses. These are the 5 where there's 1 false. Now I'm going to do the ones where there's 2 falses. So true, 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 false, false, true, true, false, true, false, true, true, false, false, true. So I'm doing 2. The last 2, then in the last 2 positions, then they're in the last 3 positions, then this is going to be the last 4 positions. Last 3 positions, maybe last 4 positions, so there's a little false there, false, false, true, false, false, true, 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 false, true, false, true, true, false, true, true, false. Okay, and then in the last 5, we start with the false, 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 true, 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 false, true, false, true, true, false, true, true, false, true, false, true, 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 false. So that those are 2 falses. Next is 3 falses. So in the last 3 spots, then in the last 4 spots, in the last 4 spots, this last 3 spots, the last 4 spots, and then the last starts with a false here. So there's going to be 3 falses. So there's 3 falses. So 2 here. Then it's going to be false, true, false. False, true. Then it's going to be false, true, false, true, false. Then it's going to be false, true, true, false, false. Those are 3 falses. Then 4 falses. False, 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 true, false, false, true, false, 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 true, false, 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 true, false, 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 true, false, 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 true, false, 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 false. And the last one is all falses. False, 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 false. Okay? So let's see if it should be 36. No, 32. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. That's all 32. Okay? So these are the all 32 ways of 5 questions, true or false. So that's the sample space. Okay, and so for each, for instance, for A, she guesses more answers correctly than incorrectly, then just make a note of the ones, oh, okay, so when she says guesses more answers right correctly than incorrectly, T is going to be correct. F is going to be incorrect. Okay, just for this. Okay, so where I put T's, this means correct. And F's means incorrect. And so she guesses more answers correctly than incorrectly. That means you would make a set where this is included, that's included, that's included, that's included, that's included. So is this, so is this, so is that, so is this, so is this, so is that, so is this, so is this, so is this, so is that. Okay, so those are the ones where more correct than incorrect. And so that's A, and then you do similar for B and C. You just choose the ones and just put them in the set for that. So that's number 2. Let's keep going. Okay, number 3. Number 3 is let A, B, and C be events of a sample space which following are true statements. So A is that A and A prime are mutually exclusive events, and that's true, right? There's A and A prime, A intersection A prime is equal to the empty set, and so they're mutually exclusive events. B, if A and B are mutually exclusive, then A prime and B prime are mutually exclusive. Well, if you look at a Venn diagram, and if A and B were mutually exclusive, and A prime and B prime are mutually exclusive, well, anything that's not in A or B, let's say little x was not in A and not in B, then if x is not in A and x is not in B, right? That can happen even when A and B are mutually exclusive. Then x is in A prime and x is in B prime. Okay, so that means that A prime intersection with B prime does not have to equal the empty set, and so B is false. All you have to do is think of an element that's not in both, that's not in A and not in B, and then A prime intersects B prime is not the empty set. Okay, and so that's part A and B of number 3. Let's look at number 4. Okay, so for number 4, it says use a Venn diagram to verify the following statements. And so for A, you want to verify that A intersection B prime is equal to A prime union B prime. And so A intersection B prime, well here, if here's A and here's B, this is A intersection B, then A intersection B prime is just everything other than what's shaded. And so that would be here, here, and here. That would be A intersection B prime. That's this guy. And then if you were to do A prime union B prime, this is A, this is B. A prime would be everything outside of circle A. Everything outside of circle B would be B prime. And if you take the union of them, here's A and here's B. You take the union of what's outside of A and what's outside of B, you get everything on the outside here. And you get, one or the other, everything outside of B, everything outside of A, and it's the same. And so the two Venn diagrams are the same. The Venn diagram for A prime union B prime is the same as the Venn diagram for A intersection B prime. Okay, so that's for A. And so you do something similar for the other parts. And then for number 5, so for number 5, it says in which of the following events are A and B mutually exclusive? So for part A, you toss a coin twice. A is the event of head on the first toss. B is the event of head on the second toss. So heads on both tosses, right, is in both A and B, because event A is heads on the first toss, B is heads on the second toss. And so A intersection B is not empty. And so that implies that A and B are not mutually exclusive. events. Okay, so A and B are not mutually exclusive. That's part A, and you do something similar for the others. So those are the answers to these homework problems, and do the next homework assignment, watch the next videos, and I'll see you next time.